Hello everyone, welcome. This educational channel expounds topics in mathematics, civil engineering, and professional education subjects. This channel aims to simplify the lessons, and I am its founder, Bert, a Filipino licensed teacher and engineer. Thank you for watching.
Hello everyone. I will discuss exact equations. This topic will be discussed in two videos, and this is the first video. As shown in the list, our topic is the third lesson in the solution of some first-order differential equation. To understand our lesson, you should have a good background on separation of variables and equations with homogeneous coefficients. If you did not yet study these topics, you may spend time watching our videos on these topics. We're going to recap the solution of a differential equation. Step 1, we identify either the equation is exact or not. If the equation is not exact, you have to apply other methods. And if the equation is exact, then proceed to step 2. We have here the partial answer of our exact equation. That is the integral of m dx plus an unknown function of y, and equate that one to c. This is a partial answer because we are still going to look for the value of this function of y. And that value can be obtained in step 3. Step 3, we are going to get the partial derivative of the function f with respect to y, and it should be equate now to our n. In the given problem, our n is 6y plus x squared. And then we can get the value here, the function of y. And the function of y here shall be substituted to this equation. Actually, this equation is just from step 2. And this is now your final answer. We're going to solve the example 4 again. But by this time, we're going to use a shortcut method. With this method, I am pretty sure that you may conclude that solving an exact differential equations is the most easy among all the methods. So, how it is done? For the solution, you will just integrate these two terms, then combine their integrals without repeating any term. So for our solution here, I'm going to integrate first the dx term. We have here the 2xy minus 4x cubed dx. That is equals, take note, this is dx, so our x here is the variable while letter y is assumed as constant. For our solution, I'm going to write these expressions into two integrals. So, we have here 2y integral of x dx. Take note, y is written outside the sign of integration since that is constant. Then, minus 4 integral of x cubed dx. Then, we have 2y integral of x dx is x squared over 2 minus 4 integral of x cubed is x4 over 4. We're not going to write the constant c in this time. We will just write the constant c in our final answer. Simplifying this, you notice our numbers 2 here is cancelled. So we have x squared, y minus our 4 is cancelled, so you have here x4. For our second term, that is 6y plus x squared dy. This time, this is dy, so the variable is y and x is assumed as constant. And we are going to write this into two integrals, that is 6 integral of y dy. Then plus x squared integral of dy. Take note, x squared is written outside the sign of integration because this is assumed as constant. So you have here 6, then we have y squared over 2 plus the constant x squared. Integral of dy is y. Then 6 divided 2 is 3. Then y squared plus x squared y. And this is now the answer for our second term. Then let's combine. For our answer, we're just going to copy the first answer, that is x squared y minus x4. Then, in our second expressions here, 3y squared plus x squared y, I'm going to copy here the 3y squared. So that is plus 3y squared. You notice x squared y is already here. So that is repeated and you are not going to copy that again. So this is our final answer and just add here the constant c. And this answer is the same to our answer before. And I'm sure this is the solution that is one of the most easy among all the methods. Let us move to the next example. Solve the differential equation 2x plus 2y plus 2x plus 3y squared y prime equals to 0. I purposely choose that the given differential equation is not in standard form to remind you that equations appear in many forms. Hence, we should write this equation in standard form, where our y prime here is equals to dy over dx. And we are going to substitute this value in the given equations. So we have here 2x plus 2y plus 2x plus 3y squared, and y prime is dy over dx equals to 0. Then multiply the whole equation by dx. So we have here 2x plus 2y dx plus 2x plus 3y squared dy is equal to 0. This is now the standard form. This is our value for m and our value for n. Let's now move to our step 1. We are going to evaluate either the given differential equation is exact or not. And to do that one, we are going to get the partial derivative of m with respect to y. And that is the partial derivative of 2x plus 2y. And that is equals to the partial derivative with respect to y, meaning y here is variable. So for the constant 2x, derivative for that is 0. And for the derivative of 2y, that is 2. Then we are also going to get the partial derivative of n with respect to x. And that is now partial derivative of n, that is 2x plus 3y squared. This is with respect to x, so x here is our variable. And derivative for 2x is 2, and derivative for this constant 3y squared is 0. Since the two partial derivatives are equal, therefore our equation is exact. For our step 2, we are going to integrate our dx term and dy terms and then combine the integrals. So we have here integral of 2x plus 2y dx. This is for our m. Again, our x here is the variable. So we have here 2 integral of x dx plus 2y integral of dx. 2y here is constant. Then integrate, that is 2x squared over 2 plus the 2y integral of dx is x. And then cancel 2. So we have x squared plus 2xy. Then we are going to integrate the dy term. That is 2x plus 3y y squared dy. This is dy, so y is our variable. So for the 2x that is constant, the integral of dy plus 3 integral of the variable y squared and dy. Then we have here 2x, integral of dy is y plus 3 integral of y squared is y cubed over 3. And then we have here 2xy plus cancel 3y cubed. For our answer, we're going to copy for the integrals of our m, that is x squared plus 2xy. Then copy also our integrals for n, but do not copy when that is repeated. So 2xy here, as noticed, is repeated. I'm not going to include that one. And then I'm going to write the y cube. Then equate that one to constant. So this is our answer. We're going to check our answer using differentiations. So the differential of our answer, x squared plus 2xy plus y cubed equals to constant. Take note, x and y here are variable. For our first term, x squared, the differential is 2x dx. For our second term, we're going to use the product formula in which our u is 2x and our v is y. So we have here u, that is 2x, then the dv, that is dy, plus our v is y and our du is 2dx. That is the differential for 2x. Plus the differential of y cubed is 3y squared dy, then equate to differential of the constant is 0. Then I'm going to simplify. This is 2x dx plus 2x dy plus 2y dx plus 3y squared dy equals to 0. I'm going to combine the 2 dx term. We have 2x dx plus 2y dx, then factor our dx. So we have here 2x plus 2y dx. Then I'm going to combine the dy terms. We have here the 2x dy plus 3y squared dy is equal to 0, and then combine them by factoring. The common is dy, and we have here the 2x plus 3y squared. This equation is the same to the given. Therefore, our answer is check. We are now going to evaluate our learnings on this topic. Our test has two parts. The first is on identifying an exact equation. The second is finding the solution. You will be given time to answer, then we will answer the assessment later to check your answer. So, this activity is just similar of having more examples. Let us now start the first part. Which of the following differential equations are exact? We have 3 differential equations to be classified. You have 30 seconds to answer. I understand you need longer time, so you have the option to pause this video while answering. After answering, you can play back the video to check your answer. We are now going to classify the differential equations. For letter A, our value for m here is 1 plus y. And our value for n is 1 plus x. We are going to get the partial derivative of m with respect to y. That is the partial derivative of our m, which is 1 plus y. Since the partial differentiation is with respect to y here is variable, and the derivative for y is 1, and the derivative for the constant 1 is 0. Therefore, the partial derivative of m with respect to y is 1. For our n, that is partial derivative of n with respect to x. So partial derivative of our n, which is 1 plus x, and this is with respect to x, therefore x is variable, and derivative for x is also 1. As shown, the partial derivative of m with respect to y is equal to the partial derivative of n with respect to x. Therefore, our equation is exact. Now let's move to letter B. Our m here is 3x squared plus 3y, and partial derivative of our m with respect to y. That is partial derivative of our m, that is 3x squared plus 3y. Since the derivative is with respect to y is the variable, and x is assumed as constant. Derivative for 3x squared, that is 0, and derivative for 3y is plus 3. In short, our partial derivative of m with respect to y is 3. For our n, partial derivative of n with respect to x, that is partial derivative of n, that is 3x plus 2y. This is with respect to x, therefore our x here is the variable and y is now assumed as constant. Derivative for 3x is 3 and derivative for 2y is 0. And the derivative for the partial of n with respect to x is also 3. As shown again, our partial derivative of m with respect to y is equal to the partial derivative of n with respect to x. Therefore, this is exact. For letter C as shown, our equations is not written on the standard form, since our dy is on the left side while the other term is on the right side. So we are going to rewrite the equation into the standard form. Hence, we are going to transpose our dx term to the left side. So we have here negative y squared dx plus 2xy plus 1 dy, and is equal to 0. Here, our value for m is negative y squared, and our value for n is 2xy. We're going to get the partial derivative of m with respect to y. And let's substitute the value of m, which is negative y squared. This is with respect to y, so y is variable, and derivative for negative y squared is negative 2y. For our n, the partial derivative of n with respect to x, and we are going to substitute our value for n, that is 2xy plus 1. Since this is with respect to x, x here is variable, and y is assumed as constant. So the derivative for 2xy, I'm going to write the constant 2y. Then the variable x, the derivative for that variable x is 1, plus the derivative of 1 is 0. Then simplify, that is 2y. As shown, our partial derivative of m with respect to y is not equal to our partial derivative of n with respect to x. Therefore, this is not exact. As noticed in this equation, if we did not transpose y squared dx to the left side, this is positive y squared. And eventually, our partial derivative of m with respect to y is positive 2y. And you will get mistake. So always be reminded that before getting the value of m and n, you should write the equation into standard form. We are now going to find the solution of a differential equation. Our equation here is 3x squared plus 3y dx plus 3x plus 2y dy equals to 0. The steps and the solutions are listed here. For the step 1, we are going to identify either the equation is exact or not. However, this equation is already given in our part 1 and we already found that this equation is exact. So you can proceed to step 2 to step 4. You are given 30 seconds to answer, and if you need longer time, you can pause this video while answering, after which you can play back the video to check your answer. We are now going to answer the differential equations. In our given equation, our value for mxy is 3x squared plus 3y. And our value for nxy is 3x plus 2y. For the step 2, function of xy is equal to the integral. Our m here is 3x squared plus 3y dx plus the unknown function of y. For this integral of 3x squared plus 3y dx, this is dx. Therefore, our x is the variable. For easy integration, I'm going to write this dx term into two integrals, and I have to write the constant before the sign of integration. So we have here 3 integral of x squared dx plus 3y. Take note, y is assumed as constant, so I have to write y outside the sign of integration, plus the function of unknown y. Then integrate x squared, that is now x cubed over 3 plus 3y, and integral of dx is x plus the unknown function of y. Then cancel 3, we have x cubed plus 3xy plus the function of y. So this is now the function of xy. Then let's move to our step 3. Our formula is the partial derivative of f with respect to y is equal to nxy. We are now going to substitute our functions of f. Functions of f, that is x cubed plus 3xy plus the unknown function of y is equal to 3x plus 2y. If we are going to get the partial derivative for this expression, it is with respect to y, therefore y is the variable. So derivative of x cubed, which is assumed as constant, is 0. Then, I'm going to copy the constant 3x for the second term to be differentiated, and the derivative of y is 1. Plus, and this is now the derivative of the unknown function of y, and is equal to 3x plus 2y. Then simplify, the derivative of the function of y is equal to, the 3x here is cancelled. So that is equivalent to 2y. As noticed, we have here the derivative of that unknown function of y. To bring it back to the function of y, we are going to integrate the equation. So we have here the integral of that function of y is equal to that integral of 2y, and we can put here dy. So this is now the function of y is equal to 2, then integral of y dy is y squared over 2. So we have here the unknown function of y is equal now to y squared. And we will now proceed to our step 4. We are going to substitute to our function of x, y is equal to the integral of m xy dx plus the unknown function of y. So for this, our function of xy is equal to our value for integral of m dx is x cubed plus 3xy. And then our value for that unknown function of y is y squared. And we are just going to add here the constant. So our answer is x cubed plus 3xy plus y squared is equal to c. At this time, we're going to spend time checking our answer by differentiations. This is our answer, x cubed plus 3xy plus y squared is equal to constant. We're going to get the differential of all the terms. For the x cubed, that is 3x squared dx. For the middle term, 3xy, I have to write the constant 3 outside the parentheses, and I will write the differential of xy inside the parentheses, that is x dy plus y dx. I am using here the product formula, plus differential of y squared is 2y dy is equal to differential of constant is 0. Then we are going to simplify. Specifically, I'm going to simplify the middle term. For the other terms, I will just copy. I have here 3x squared dx. For the middle term, I will distribute the constant 3 to the terms inside the parentheses. So we have 3x dy plus 3y dx. Plus, I will copy the fourth term, 2y dy is equal to 0. Then I have to group the dx term. That is 3x squared dx plus 3y dx. Then I will also write the two dy terms here. 3x dy plus 2y dy is equal to 0. Then I'm going to factor out the dx in the first two terms and write the coefficients inside the parentheses. We have here 3x squared plus 3y. For the last two terms, we have here the common is dy, and again, and the coefficients of dy are 3x and 2y. You notice this differential equation is the given problem. Therefore, our answer is check. We're also going to try to solve the problem using our shortcut method. For step 1, we're going to find the integral of our m xy dx. So that is integral of our m is 3x squared plus 3y dx. This is derivative of x, and we are going to assume y as constant. Again, I'm going to write this into two integrals, and the constant will be written outside the sign of integration. So we have 3 integral of x squared dx plus 3y integral of dx. This is 3x cubed over 3 plus 3y integral of dx is x. So our answer here is x cubed plus 3x1. Then we are going to integrate
our n. So we have here integral of 3x plus 2y dy. This is dy, therefore x is assumed as constant. Similarly, I'm going to write this into two integrals, and the constant will be written outside the symbol of integration. So 3x as the constant, integral of dy, plus 2, the constant, the integral of y dy. Then integrate, we have 3x, integral of dy is y, plus 2, integral of y is y squared over 2. And finally, the answer here is 3xy plus y squared. For our answer, we're going to combine the integral of m and the integral of n. But when the term is repeated, we are going to write it only at one time. So, for the integral of m, we have x cubed plus 3xy, and add the integral of n. We have here 3xy, which is repeated, so I will not write it anymore here for the combination. And I will write the y squared, which is not repeated. Then, that is equal to constant. And this is now the final answer. As notice, this is the same with our previous solution. Hello everyone, this is the end of our discussion on exact equations. You can now proceed to the next video, which is the linear equations of order 1.